Thank you, viewers. This is Mr. Odingo, and I want us to move on from our previous lessons that we have learned about. We started with the differentiation, and thereafter we looked at area approximation. Today, I want us to do integration. And before we begin, I want to appreciate all Kenyans for supporting us and also taking their time to learn with us, especially those our students that are at home during this time. So we take this opportunity to welcome you so that you can continue benefiting from our lessons. Now, I want us to look at integration, which basically is the reverse of differentiation. So we have learned how to differentiate a function, and now we want to learn how to integrate, to go back to that original function after you differentiate. We know that usually when you are differentiating a function y equals to x power n, we know that first you multiply this here by n, and then you subtract 1 from that power. That one brings you, when you multiply by n, you have nx power n, and then you subtract 1. That is differentiation. But assuming if you have that function and you have to integrate it, what we have said is that you add 1 to the power first, so it will be n plus 1. After you get n plus 1, then divide by the new power. The new power now is n plus 1, so you get n plus 1. Now you realize that when you are doing this particular thing, you are doing the opposite of what we have done up here. So initially, if you had, assuming you have y equals to x power 2, x power 2. So if this is dy dx, this is dy dx. If you have to deal with now y, assuming you are getting the function from this particular gradient function, you'll say y equals to, we know that what you have said is that dy dx, dy dx, if you are getting dy dx of this function, you get, if you have x squared as dy dx, the gradient of the function, if you are getting y, we said you are doing the opposite. Initially, we subtracted 1 from here when you are differentiating. So if you are differentiating, you subtracted 1. What you are going to do is that you are going to add that 1. So 2 plus 1, because initially we subtracted it. So when you are going reverse, we add that 1. After we add that 1, what we do is we know that this one was multiplied. This power was multiplied here initially. So the reverse of multiplication is division. So we are now going to divide by the new power, which is 2 plus 1. I've said that if you're dealing with, let's say we have y equals to 3x power 3. That's the function that we have. And that function here, we are differentiating it. For us to differentiate, the first thing we said, we take this one here. If you take that one here, let's say it is y equals to x cubed. If you take this one here, you will get dy dx equals 3 here will be 3x. So the first thing we have brought 3 here. Then we subtract 1 here, so that will be 3 minus 1, which will be 3x power 2. Now, if we are going back, assuming now we have dy dx is 3x squared. Dy dx is 3x squared. So you have dy dx is 3x squared. You have to get the reverse of that. What we did last year was to subtract 1. So we are going to start with what we did last in differentiation, which was subtracting 1. The opposite of subtraction is addition. So we are going to say y here will be the opposite subtraction. We add 1 here, so it will be 3x power 2. We add 1 to it. That was the last thing we did. Then the first thing we did, before we subtracted 1, we multiplied what was here, which we now say is 2 plus 1. We multiplied here. So the opposite of multiplication there is division. So we are going to take this term here, we divide here with it. So that is 2 plus 1. So we are going to get, this is 3 over 3 x power 3, which is actually x power 3. but that's now the how to differentiate the opposite of I mean how to integrate the opposite of differentiation. You realize that most functions, our function here, do not have a constant. It's just a single term function. But sometimes you may find a function with a term. So sometimes it's very important that after differentiating, you actually say, if you have said y equals to x cubed, it's good to say plus c, because we don't know, maybe it was x cubed plus 2, x cubed plus 3. This c here, we are going to see how to obtain it later on. So that's what actually we are doing in this process here, where when you are integrating, we do the reverse of what we did in differentiation. We know we started by multiplying the power by the function, then we subtracted 1. So what we did last is what we do first when you are integrating, you add 1, then finally you do the opposite of multiplication that you did, which is actually division. Now, I've said that when you differentiate a term with constants, this one is what we call a constant here. It's actually what we can refer to as the y-intercept. This 5 here. Here it is negative 19. For this function here is 0. Now if you differentiate all these terms, you realize that all these terms will give you the same gradient function. If you differentiate this one also, it will be 2x dy dx. If you differentiate this one also, you'll have 2x here. You realize that it's kind of confusing to believe that all these functions have the same gradient function, but that is because the constants here, derivative of this constant is 0. Derivative of 5 is 0, derivative of negative 19 is 0. Here there was no constant, is therefore still dy dx of 0 is 0. So what we are going to say that if you are differentiating, it's very important that you express your function that you get in terms of a constant c that we don't know, so that if you know the value of y, or if you have the coordinate, then you can move forward to be able to determine that particular missing value of c. So it means that if I want to integrate this function here, if I told that dy dx is actually 2x, and then have to be able to integrate this function, what I'm going to do is to also do the reverse of what I've done. I know that 2x here is the same as 2x power 1. It means I can simply say y equals to, we said that the first thing we do is to add 1 to the power of x that we have there. Then the second thing, divide by the new power, which is 1 plus 1. So we are going to get here is, so we add plus c. The reason we are adding plus c here, it means that this c could be 5, it could be 0 in this case, it could be negative 19 in this case. So this c here is actually arbitrary c. We can only determine the actual value when we know the coordinate, at least one coordinate in this particular function, one of them. So here, if you simplify, this curve should be, in terms of 2 over 2 is 1, so you're going to get x squared plus c. So if c is 0, we are going to have this function here. If c is 5, we are going to have this function here. If c is negative 19, we are going to get that particular function there. Now, what about if we have or a gradient function dy dx equals x power n? We have said that if you have this one, then it means that the function y equals to, we said we add 1 there, so it will be x power n plus 1 divided by the new power, which is n plus 1, then plus c, where c there we have said is arbitrary constant. Every time you integrate, you have to put it there. What about if now our gradient function has got a coefficient? In this case, the coefficient is 1. What about if it has a coefficient which is more than 1? So we are going to say if dy dx equals a x power n, then let me say if, let me start here by if, then say then y equals, let's integrate this one, we add 1 to this power, so it will be ax power n plus 1. Then we divide what we have here by the new power, which is n plus 1 plus c. That is what we have. Remember, for this both cases, n cannot be equal to -1. What do we mean by this? Why is n not supposed to be -1 in either of these cases? If 1 is -1, we are going to have something that is not possible, because any number divided by 0 is actually a very big number that a calculator cannot really recognize or write down. So if you have -1, if n is -1, it will -1 plus 1, which is 0. So that is going to present a very big challenge to us. So we should not be able to deal with this one if n is -1. That will not bring for us a solution. So these are rules of differentiation. Integration. These are integration rules that we need to do. You realize that they are just reverse of what we did before in differentiation. So the first one is when the coefficient of the function is 1, and this one when the coefficient is more or less than 1. But if it's less than 1, it cannot be -1. X. Now let me just start by 3x squared. Now if you have to integrate 3x squared, you have to assume that this one here is the gradient function. So it's also logical to say dy in this case, dx equals to 3x squared. So if you are integrating, we say y, because we are going back to y. This was dy dx, so we are going back to y, which is going to be 3x squared plus 1. Everything divided by 2 plus 1, then plus c. So we'll say y in this case equals to 3 divided by 3 is 1, so you'll get x power 3 plus c. That is the function after integration. What about b? If you have d, or if you have 10x power 4 minus 2x minus 2x. If you have that one, what we are going to do is, we realize that this one is now a polynomial. We can write it as y dy dx equals to 10x power 4 minus 2x. So if you are getting y, meaning we are integrating, we are going to say y will be 10x power 4, we add 1, then we divide by 4 plus 1. Then minus 2x power 1. We know 2x is the same as 2x power 1. Then we add 1. Then again we divide by 1 plus 1. Then we add c, because there must be a arbitrary constant there. So y in this case will be 10 divided by 5 is 2. So it will be 2x power 5 minus 2 divided by 2 is 1. So x power 2 plus c. That is what we have if we happen to integrate those particular functions. So you realize that if you have a polynomial, then you just have to integrate each of the terms forming that part. We integrate it in parts, or by parts. So this is c 4x cubed plus 2x squared 6x squared plus 14x minus 5. Assuming we have to integrate this one, the first thing we do is to say this is dy dx. It is 4x cubed plus 6x squared plus 14x minus 5. So if you are getting y, in this case we are going back to y, we'll say y equals to 4x power 3, we add 1, then we have divide 3 plus 1, plus 6x squared plus 1 divided by 2 plus 1, plus 14x, which is the same as 15x, the same as 14x power 1, plus 1 over 1 plus 1 minus 5. 5 is the same as 5x power 0. That's what I want you to know. Because any number 10 can be written as x 10 power 0, 10x power 0, because x power 0 is always 1. So I want to invite you to know that if you have 5, it's the same as 5x power 0. So we add 1 there, then divide by 0 plus 1. Then finally plus arbitrary constant c. So y in this case will be 4 divided by 4 is 1, so that is x power 4, plus 6 divided by 3 is 2, 2x power 3, plus 14 divided by 2 is 7, x power 2, minus 5, 0 plus 1 is 1, divided by that is just 5x power 1. X power 1 is just x, then plus c. This is now the derivative or the integral of this particular function if we actually happen to integrate it. What about d? If you have dy dx equals to 5 over x squared. If we have this particular plus 3, if you have this particular case here and you have to integrate, still there is no big deal. We first of all have to rewrite this particular function in terms of a linear one without fraction. We remove the fraction. Removing the fraction here meaning we get the reciprocal of this function of the 1 over x squared, which is the same as dy dx here will be 5x power negative 2, then plus 3. So if we integrate this one, we are going to say y will be 5x power negative 2 plus 1 over negative 2 plus 1, then plus. We say that if you have now a constant, then it means it's the same as that constant power x, x power 0. So I'll say plus 1 here over 0 plus 1 plus c, because there must be a arbitrary constant there. So y will be, we know that negative 2 plus 1 is negative 2 plus 1 is negative 1. So we are going to have 5. This is 5 over negative 1. So it's going to be like negative 5. X power negative 1 plus, this is going to be 3x plus c. But to realize that, we know that if we have this one, we can still bring it back to this one over x plus 3x plus c. We can still write this one in this form, although not very compulsory, but you can still express it this way because that's how equation was given to you earlier on. dy dx is a, we have 4ax cubed, 4ax cubed. So dy dx is this, dy dx equals to 4ax cubed. Now, one thing we have to know in this particular case is don't worry about the unknowns. We are just going to say y in this case is equals to 4ax cubed plus 1 divided by 3 plus 1, then plus c. So in this case, if we have this one, let us simplify. We know that 3 plus 1 is 4. So if 3 plus 1 is 4, you are going to get something like 4ax power 4 divided by 4, then plus c. We know that 4 and 4 will cancel, so we'll get y equals to ax power 4, then plus c. What about b? b is x cubed minus 4x plus 4, everything divided by x or 3. Now we know that this is dy dx, let me express this as such, equals to, I want to break every part because this denominator is for every term here. So I'm going to say this is x cubed divided by x cubed minus 4x divided by x cubed plus 4 divided by x cubed. That is fairly easy. Then if I go further, divide the x to simplify, this will be 1. 1 minus 4 over x squared plus 4 over x cubed. So what we are going to do in this case is to remove the fractions, and this is dy dx equals 1 minus 4x power negative 2, if we get the reciprocal of 1 over x squared, plus 4 plus 4x power negative 3. So if you have that one, we can therefore say y equals, we know 1 is the same as 1x power 0 or x power 0. If we differentiate, we add 1 here, then we divide by 0 plus 1 minus, here we get 4x power negative 2 plus 1 over negative 2 plus 1 plus, here we get 4x power negative 3 plus 1 over negative 3 plus 1, then plus c, the arbitrary constant. So let me have a line here. We are going to have y equals to, this is just x. If we have this one here, we know negative 1, that is, this is negative 1, so 4 over negative 1 will just be positive 4, because negative 2 plus 1 is negative 1, so then negative 4 divided by negative 1 is plus 4. Up here we are going to have x negative 1, then plus, here we are not going to have plus but minus, because if you have negative 3 plus 1 is negative 2. This is 4, positive 4. So positive over negative 2, we should have negative 2. X power negative 2, then plus c. So we'll get y in this case, if I write in fraction, 1 over 4 over x minus 2 over x power 2 plus c. That is the function that you are supposed to get if you do it properly. Now question 3 or part C. Part C in this case is 1 minus 4x into 1 plus 4x. Now you realize that this one, we have to first of all deal with the brackets before we move on. So if you have to deal with the brackets before we move on, we know that 1 minus 4x, 1 plus 4x, these are different to 2 squares. So the first thing you do, just multiply that with that, also multiply that with that. But the difference, we say we are difference. The difference meaning subtraction. So 1 times 1 is 1 squared, minus 4x times 4x is 16x squared. So we are going to have that 1 minus 16x squared if we expand, and this is dy dx. So the first thing we have to do here is to open the bracket, and I've said opening bracket for a difference of 2 squares is very easy. So if you have to get y, will be 1 is the same as 1x power 0, which is going to be added to 1 over 0 plus 1, minus 16x squared plus 1, everything divided by 2 plus 1, then plus c. So y in this case will be x, because this is x power 1, this is 1, so 1 divided by 1 is 1, minus 16 out of 3. 16 out of 3 x power 3, then finally plus c. That is what we are supposed to get in that particular case. Then let me go to the last one in this case, which is x plus 3 squared. Now x plus 3 squared, earlier we have been talking about quadratic identities, which we said that if you have x or a plus b squared, this is the same as a squared plus 2ab plus b squared. That is your Form 2 lesson. So you realize that if you apply the first quadratic identity here, where x is our a and 3 is our b, then we are going to say x squared, a squared is going to be our x squared here, plus 2 times a, which is x, so that is 2x, times b, which was our 3, 2x times 3 is 6x, plus b squared, which is 3 squared, is 9. So we know that we can say dy after expanding dx equals to this one. So from here we can say y will be x power 2 plus 1 over 2 plus 1 plus 6 into x. X is the same as x power 1. Then we add 1 over 1 plus 1 plus 9. 9 is the same as 9x power 0. So plus 1 over 0 plus 1, then plus c. So y here equals, this is the same as 1 over 3, because there's a silent 1 here, this is 3, x power 3, plus 6 over 2 is 3, x power 2, plus this is 1, so 9x plus c. Now viewers, I want to invite you to understand what we are doing when we have a constant. When you have a constant, any number, number without a variable, in this case any number without x, will always be with x power 0. That's something you must not forget. If I give you 10, you must know it is 10x power 0. Every time you see a constant, the number without a constant or variable, express it in terms of x power 0. That's where I know most of the learners will get stuck. So viewers, we have known how to integrate. In our next lesson, we are going to see how to find the values, how to get a function. C is given as arbitrary value. We don't know the actual value of C. So in this case, we want to find that value of C, and in which, if we get the value of C, then we can get the actual value of the equation of the curve. Now, we say that if you want to find the value of C, the first thing you need a coordinate, at least one coordinate where that curve is passing through. So if we get that coordinate, we can be able to substitute in the equation both value of x and y. From there, we can be able to get the constant which do not have any value. Once we get that constant, we are able to substitute it where it's necessary so that we get the equation. Like in this case, we have said that the steps for finding a constant of integration: first, we integrate the gradient function. After we integrate it, we substitute the values, at least the values of x and y of a point where the curve is passing. Then we solve the equation. Once we substitute these values, we are going to create an equation, just a normal linear equation where we can solve to help us get the value of c. So to get the actual value or the actual function, we substitute c in the function. So let's look at that example following those steps. We say that this is dy dx, and it passes through this point. So the first thing, I want to get y, where y is going to be 3x squared. We add 1 here over 2 plus 1 plus, we say 2, a constant is the same as that times x power 0, then plus 1 over 0 plus 1, then plus c. So if we solve this one, this is 2 plus 1 is 3, so 3 divided by 3 is 1. So we are going to say y here equals to x cubed plus, this is 1, so that's going to be 2x, then plus c. So now we have the function here is y equals to x cubed plus 2x plus c, but we know we need to get c. This function or this curve passes through point 1, negative 1. So I'm going to substitute x, 1 for x, and negative 1 for y. So I'll say, if I bring negative 1 where y is, I'll say negative 1 equals x cubed, and x is 1, so 1 cubed plus 2x, that is 2 times 1, plus c. We don't know the value of c, so let us see. This is negative 1 equals to 1 plus 2 plus c. Negative 1 equals to 3 plus c. If we bring 3 to this other side of the equation, we'll get negative. So this will be negative 1 minus 4 minus 3 equals to C. This is negative 4 equals to C. So we have got C being negative 4. So after we get C there, we can substitute it in the equation to mean that y, the curve is y equals to x cubed plus 2x minus 4. This is going to be the curve, the actual curve. So you realize that by doing this, we are able now to get the value of C. So the function will not actually just be in terms of C only. Let us see part B of the equation. So we have the gradient function here is being 3x squared plus 2x, and it passes through point 2, 10. The first thing, like I said, let us get y. Let's integrate. So it will be 3x2 plus 1 over 2 plus 1 plus 2x, and we know x is the same as x power 1 plus 1 over 1 plus 1 plus c. So this will be y equals, we know 3 divided by 3 here, 2 plus 1 is 3. So 3 divided by 3 is 1, that will be x cubed plus, this is 1 plus 1 is 2, so 2 divided by 2 is 1, that will be x power 2 then plus c. So then we substitute this one here, x, 2 for x and 10 for y. So what y is 10, x is 2 cubed plus 2 squared plus c. This is 10 equals 2 cubed is 8 plus 2 squared is 4 plus c. So if we move forward, we are going to have 10 equals 12 plus c. So if you bring 12 here, it will be negative 2 equals to c. So we can therefore substitute c for the integrated value, which is y. Y was equals to x cubed plus x squared minus 2. This is now the actual function of the curve. Now part C dy dx equals x plus 2 squared at coordinate 1, 7. Coordinate 1, 7. The point where the curve is passing is 1, 7. Gradient function is this. I said that if you have this one, the first thing you do is to expand. So to expand that one using maybe a quadratic identity, you can use the long method to expand, but I'll use quadratic identity. Well, let me now use the long method. I know some learners have issues with this particular thing. So let us say this is x plus 2 times x plus 2. That's what it means. This is dy dx. So if you open bracket, it will be x into x plus 2 into x plus 2. This will be x squared plus 2x plus 2x plus 4. This is x squared plus 4x plus 4. This is our gradient function. So if this is our gradient function, we can now move forward to integrate, where we are going to say y will be now x plus 2 plus power 2 plus 1, 2 plus 1 here, plus 4x, and x is the same as x power 1, then plus 1, 1 plus 1, plus 4. And we say that 4, any constant is the same as that constant to the power, the x power 0, then plus 1 over 0 plus 1, then plus c. So we'll get y equals, this is 3, so 1 over 3 is the same as a third, x cubed plus, this is 1 plus 1 is 2, 4 over 2 is 2, so 2x power 2 plus, this is 4, 0 plus 1 is 1, 4 over 1 is 4, x power 1, but power 1 is just 1, so plus c. we know that the curve passes through point 1,7. So we are going to substitute 1 for x and 7 for y. So we say 7 here equals to a third into 1 cubed plus 2 into 1 squared plus 4 into 1 plus c. We know that 7 here equals to, this is going to be a third, because 1 cubed is 1 times a third. It's a third plus 2 plus 4 plus c. So we know that this is 2 plus 4 is 6. 6 plus a third is 6 and a third. So 7 equals to 6 and a third plus c. So if you want to get the actual value of c, we are going to say c here will be 7 minus 6 and a third. And c here, if I'm not wrong, will be 2 thirds. Let me see that. 7 minus 1, 6, and 1 over 3. 2 thirds. So we substitute in this here. We substitute our c. So our c here will therefore be y equals to a third x cubed plus 2x squared plus 4x plus 2 thirds. This is the actual value or the actual function. That is the actual function 0. So let us move forward. We know that if this is y will therefore be, if dy dx this will be 9x squared plus 1, 2 plus 1 here, plus 4x, and 4x is the same as x plus 1. We add 1, then 1 plus 1, minus 3. We know that a constant, I said, must be times power x times x power 0 plus 1 over 0 plus 1, then plus c. So y here will be 2 plus 1 is 3. So 9 divided by 3 is 3. 3x power 3 plus 4 divided by 2. 1 plus 1 is 2. That will be 2x squared minus 3x plus c. But we know that the point at which this line passes is at negative 1, 0. So I'll say y0 for y equals to x is negative 1 cubed plus 2 into negative 1 squared minus 3 into negative 1 plus c. So 0 here equals to negative 1 cubed is negative 1 times 3 is negative 3 plus negative 1 squared is 1 times 2 is 2 plus negative 3 times negative 1. Positive times negative is positive, that is 3, then plus c. So you can have negative 3 minus 3 is 0. So I'll have 0 equals to 2 plus c, because this and this will cancel out. So I'll say that negative 2 here equals to c. So the equation now be, if I substitute back here, it will be y equals to 3x power 3 plus 2x squared minus 3x minus 2. This is the function. If you differentiate this one, believe me, you are going to get this one here. So viewers, that's the end of this lesson. And so far we have looked at how to integrate and express your function in terms of arbitrary constant c. Now we have been in the second lesson, we have looked at how to be able to find the actual function by determining the constant c, the value of the constant c, if you are provided with the coordinate of a point at which the curve passes. So using that, we are able to get the value of c and substitute that value of c in the curves so that we get the actual function. So viewers, that will be the end of our lesson. The next lesson we'll be talking about the definite and indefinite integrals.